Consider the function y is 4x cubed over 3 minus 16x, where x is real. The graph of y is f of x has a local minimum point at pq where p is greater than 0. Find the value of p and the value of q. So to be a local minimum at some point, at that point, what derivative must be 0. So to find the local minimum or local maximum, or it's also called the turning point, we should find derivative and then equate it to 0. So let's find the derivative. It becomes x cubed derivative. It's 3x squared. 3 cancels, so it becomes just 4x squared minus 16x derivative. It's just 16, and it should be 0. And we need just solve for x. X squared is 4. So in general, x is plus minus 2. But as p is greater than 0, here it is given, but in general we should check, and as p is greater than 0, hence p is 2. And in general, how to find out whether it's a local minimum or local maximum, we can find, for example, the second derivative, and the second derivative becomes 8x, and second derivative at 2, it's positive, and second derivative, when second derivative is positive, it says that the curve is concave up at that point, and concave up implies minimum. And if we consider the second derivative at -2, it is negative, and negative implies that curve is concave down, and concave down, it means that it's a local maximum. Another method is to consider a point to the left and to the right. So for example, consider if we want to check point 2, we can consider derivative at 1 and derivative at 3. You can take any point to the left up to -2, or actually maybe consider it 0 to be easier to calculate. So derivative at 1, it's negative, and derivative at 3, it's positive. And derivative is negative, it means the curve is decreasing, and at 3, curve is increasing, and at p is 2, there is horizontal tangent. It's because derivative is equal to 0, and points where derivative is 0 are called stationary points, and since function is decreasing to the left and increasing to the right, hence it's minimum. And the same for -2, you may consider derivative at -3 and derivative at 0, for example, and at 0 it's negative. It's -16. At -3 it's positive, and hence it increases then decreases. Hence at x is -2, there is a maximum, local maximum. But here it is given directly that p is positive, so p is 2. And to find q, this point lies on our curve, so x and y coordinates of our point are linked by this function. So to find q, with just q, it's y of 2, it's just the value of a function. For x is 2, so substituting 2 for x, we get that it becomes 2 times 2 cubed over 3 minus 16 times 2, and it becomes 8 times 4 is 32 over 3 minus 32, and we can factor out 32, and it becomes 1/3 minus 1, which is -2/3, so it's -16 64/3, and hence PQ it's what, 2 and negative 64/3. And that's all for this question.